All right, let's do a little bit on covalent layer lattices and what they are. So a covalent layer lattice, we're on the next page now, so we're on the third page of the Networks and Nanomaterials booklet, and it talks about another allotrope of carbon. So this other allotrope of carbon, this one is called graphite. This is really important for Unit 4. You talk about them as their Unit 3 and 4, so they talk about them in the use of electrodes. So I'm going to go through why they're used as electrodes and how their properties are different. So you need to be able to contrast the two different structures, the diamond structure and the graphite structure, and also think about how they contribute to their properties. So let's read our notes. Another allotrope of carbon is graphite. Graphite structure is very different to that of diamond. Carbon atoms are bonded to 3. Yeah, so have a look at this guy in the middle here. Yeah, he's bonded to 1, 2, 3. Yeah, and you could pick another one over here and you would go 1, 2, 3. Okay, so they're not bonded to 4 this time. Graphite are bonded to 3. So what they do is they form these little rings, and these rings form layers, and they're pictured in this picture we can see here. So within the layer, we have very strong covalent bonds. So that's within the layer. But between the layers, relative to this, we have very weak dispersion forces. So think about that. Are you likely to break apart the middle of a layer, or are you likely to have the layers move over each other? Yeah. So the bonding between the layers is very weak and attributed to dispersion forces only. So each carbon atom in graphite is bonded to 3 others, which leaves the 4th electron free. So now, in addition to this, what we actually get, I'm just going to take off these markings here. What we actually get is floating around in here are a bunch of those 4th electrons that would have been on those carbons. So now what do we have? We have a free moving, because it can move around, charged particle. What do we think a property of graphite is going to be then? So what do we use it for? Graphite is used as a lubricant. So it's what we call a dry lubricant. So you can spray it. It's kind of like a grayish powder. Why might you use it as a lubricant? What do those layers like to do? They like to slip past each other. So it makes sense. If you put one layer on one substance, one layer on the other substance, it's going to enable them to move past each other. The most common use for graphite that you probably know are your lead pencils. So we don't use lead in your lead pencil anymore. They used to many moons ago, but nowadays we use graphite. So graphite, that means that every time you draw with a pencil, what you are doing is you are leaving a layer of carbon atoms behind on your page. So I often find when you think about this, you'll never look at a drawing again the same way. Every time you make a mark with that pencil, what you are doing is leaving behind a layer of carbon atoms. You're stripping it from the layer lattice that's in the lead that's there. Pretty cool. And then the biggest use that you're going to talk about next year are these guys in the middle. So that's their use as electrodes. Okay, why would they be used as electrodes? Think back here. They have lots of free moving electrons between those layers. Now we can see why. So this time we've only got 4 properties that we're going to talk about. The first one is that it's very soft. So automatically, this is so different to diamond. Diamond has got this really hard network lattice. This has got a very soft one. And that's because the bonding between the layers is weak. So if the bonding is weak, then that means the layers are going to move off and be separated quite easily. So it says in the notes that it's soft. The bonding between the layers is very weak, attributed by to the weak dispersion forces. This causes the layers to slide past each other with relative ease. This gives us its property for lubrication. This gives us its property for lead pencils. It's got a very high melting point. Remember, there are still lots of covalent bonds. So the fact that there are still lots of covalent bonds means that it's not going to want to melt. Now, this can be helpful when we have a look back here and see that massive amount of heat that's being generated. You don't want your electrode to melt. So having a high melting point is really helpful for that electrode there. So high melting point, strong covalent bonding is present within the layers, and a great deal of energy is needed to break them apart. It's a very good conductor of electricity, yeah, because we have these free moving electrons in between those layers. Delocalized electrons give graphite the ability to conduct electricity in a solid state as they are charged and moving. The last one is it's also quite a good conductor of heat within the layers. Okay, so within a layer, you're going to get a good conductor of heat, but between the layers, not so much, because they only have those weak dispersion forces. So they're going to move apart very easily. But remember, if you're locked into this 6-carbon kind of ring, then what happens is one starts to vibrate, the next starts to vibrate, and your energy, your heat energy is going to be transferred through that substance really, really easily. So that's all we're going to do on carbon this year. That means you can go on to 8.1 and you can do those questions. And there's only one question in question time, so you can do those as well. There is this PowerPoint on SharePoint, so you can have a read of nanomaterials. Your notes will cover nanomaterials. But I'm pretty sure we're not going to examine you on that this year at all. It's not something that's tested in 3-4, and we're not going to test you on it in 1-2. So read it for interest, because there are some very cool things that are happening. So you've got things like these spherical fullerenes, you've got these cylindrical carbon nanomaterials, you've also got graphene. Graphene is super cool. That's your carbon fiber. And then it goes through a little bit of a summary table at the end. But you don't need to know, because you are not being examined on those this year. So that is the end of carbon materials at the moment. So that's all of your 7 notes should be done after this.